Alright, BCA-101. This would have been Monday. (11/28/16). So, we talked about designing information systems. So this is a little bit of review. Talk about top-down design. This is used for information systems that are complex and or cannot have any faults. You know, they can't fail, like an airline reservation system, or not reservation, but an airline traffic control, or running the subways in a big city or whatever. So you figure out, you define the problem. Investigation. You have some reason you want to have an information system to manage something. So you have some issue, and then you analyze it. You figure out what information is needed, what information needs to go to who, how crucial, what points is it that it can fail or not fail. You figure out, is it going to be cost effective to do this? Is there benefits? Is there, you do a cost analysis and so forth. A lot of work put in the analysis. A comparison would be if you were going to build a new house. Okay, you would do a lot of analysis before you would start digging a hole or buying a lot. Part of that analysis would be the cost, how big of a house, you know, what's going to be involved, and so forth. Why you need to build a house, so forth. So that's a good analogy. Next is the design. We write flow charts, we have pseudocodes, we have lots of different ways to design solutions to information systems. You draw out how it's going to look, what information is going to go to who, and so forth. This is really like a blueprint for a house. And we really don't need to know any more than that about that right now. Okay. Development stage, we're going to talk more about that. You can buy software to accomplish your goals here in your design, or you can make software. Making it's way more expensive, but it might create for you a competitive advantage. So I gave the example of Walmart. Walmart has a very sophisticated information system. It allows them to manage their business very well, and they developed it themselves. It was expensive, and now other companies would like to hire the Walmart people who develop that IT to help them with theirs. Next step, implementing. You can completely do a complete conversion, direct conversion. You can phase it in, or you can run a pilot in a certain location, or whatever. So there's different ways of implementing. This is going from the old to the new method. From the old to the new. Then very important to evaluate to see if you're actually getting your cost value. You know, is it really doing what it should do? And then there's always maintenance. Maintenance is a big deal. If you've ever seen software updates, maintenance. So you see things that need to be improved, and what this does is you create a cycle. So you investigate the new issue, you analyze what it is, you design a solution, you write the code, you implement it, and you check to see if it works. And then if you run into another problem, then you go through the same process. This is often referred to as a life cycle, because you can only fix it so many times. It's kind of like a car. That sounds crazy, but you keep fixing the car, and you keep maintaining the car, and eventually it gets so bad that you gotta bite the bullet and develop a new strategy, like buy another car. Alright, so this part where we talked about do you buy or do you code, and I gave a brief overview of programming. We write programming coding in a programming language like Python or C#, C++, old ones like Pascal, COBOL, Fortran, all of these different programming languages. Okay, and so what a programmer writes is source code. The source code is then either compiled or interpreted to match whatever operating system it's going to run on, and then you have an object code. Then you bring in other code, you link in other code to get an executable, and that's what you distribute, the executable. So when you get a software program like from Microsoft, like Microsoft Word, it would be Microsoft Word, and then there's that exe behind it. It's an executable. They've done all this work to get it here, and they designed it to work on an operating system like Windows 10. Okay, so people can design. Anybody can do this. Anybody can do this. I mean, if you have the skill, you can get a programming language. You can create the source code. And you compile it. Let's say you're creating an app, some little cool app to run on an Apple. You would compile it to match the Apple iOS. Bring in other code to make it work, and then you create an executable app that you can either license more or less, like sell, or you can make it open source. Open source means somebody else can come back and adjust the source. Alright. Okay, then we moved into talking a little bit about databases. So I reviewed levels of management and levels of information. We got workforce, communicates to the data, and then we have these different levels that tend to communicate the data. So we can take this huge database and summarize it so the right people get the right information. I talked about an example where it took 90 seconds to get the same information it took 3 weeks for another company to get. And why? Because of how well the information system works. And then we did a little database review. I mentioned we have the tables. A couple key things. When you create a table, we create an entity. Right, they're the same thing. We have records in the table, and we have fields or attributes. All these fields. And when you create them, you create the type of field, whether it's a numeric or string or a date and time and so forth. Then, from these fields, we can put one field connected to another here and build a relationship. So when this record matches this record, you can pull things out of both tables and create a query or some report or whatever. Alright, so that's it.